Hello everyone, my name is Allison Curler and I will be talking to you today about a networking plan I have created for IBM. This plan is made specifically for IBM and will ensure a reliable, fast, and secure network. IBM is a company that operates in over 170 countries with 400,000 employees and offices in every major city in the United States. With a company the size of IBM, producing as much revenue as IBM, and having as many offices as IBM, it is vital to have a company that survives a network that is specialized to fit its needs. And this is what I will present to you today. The first thing you might be thinking to yourself is why? Why is it so important to focus on a network when there are so many other things to worry about? Company sales, marketing campaigns, product development, manufacturing and distribution of goods. Well, the answer to your question is because with a secure, functioning network, none of this can happen. Without a network that can hold the capacity of each of your office locations and connect them all to a central server in your headquarters in New York, your network will not be able to function for your day-to-day operations. Let me help you out. Here I focus on 5 of the major branches of IBM: Tulsa, Oklahoma, Austin, Texas, Silicon Valley, California, Rochester, Minnesota, and the headquarters in Armonk, New York. The entire network of IBM is going to be created at a 8-bit submask, which resembles the 10 in the position of the first octet. As you move to the second octet, you will notice that the number will be specialized based on each of the branches. 10 is for Tulsa, 20 is for Austin, 30 is for Silicon Valley, 40 is for Rochester, and 50 for the headquarters. These numbers are used to divide the network into smaller, specialized networks to create a faster and more organized use of your IP addressing. All of these locations have a subnet mask of 16, but will further be subdivided into 24-bit masks based off the different floors in each branch, which resembles different departments. This diagram gives a quick overview of how each branch is connected together. We have each of the 4 branches on the outside corners of the diagram, and the headquarters branch sitting in the middle, which connects all the branches to a single network. We'll go into each of the branches more specifically. The network for Branch 1, Tulsa, Oklahoma, is displayed above. The branch is divided into 3 different floors. The training and tech floors are active office floors where employees are utilizing company laptops and desktops like in the display. The basement is where the central server for the branch will be stored. The core switch, which connects the router for the entire branch, is sub-connected to a switch that is present on the training and the support floors. The connection between the switches and the routers is a fiber optic cable, which is strong enough to hold great bandwidth and accuracy for this branch. The next branch is Austin, Texas. The layout of this branch is a router on a stick setup, which means there's a central router that connects to one switch, which then connects to an intermediary device in each department, which in this case would be another router. Each of these routers therefore connects to an access switch that's connected to each of the end devices for the department. The extra use of switches will allow you to add nodes as needed if the department size grows. The warehouse server is on the warehouse floor, which will provide IP addresses for the PCs that are located on the warehouse floor. Although each floor seems separate, PCs can still print on the shipping floor because the request is able to pass through the router into another subnetwork. Instead of using the core switch to connect to each switch on the other 2 floors, we have a switch that is connecting a router on the other 2 floors. This adds more complexity to the network because it subdivides the network into subnets based on the floor. In order for these floors to talk to each other, communication must move through the router and be switched at the core switch in order to properly transmit information. The extra utilization of routers over switches is beneficial for this branch because it divides the broadcast domain into 3 parts instead of allowing broadcasts to the entire network at once. This will enhance network security and performance. The third branch is Silicon Valley, California. This branch contains one router that is used to divide the network into 4 separate VLANs, which utilizes little equipment and speeds up communication by limiting the broadcast domain. The marketing and sales to servers are in the IDF, which is the wiring closet. Each server will distribute IP addressing to their given department using the DHCP protocol. The printer is located in its own VLAN, which is separated with the router 3. Both the sales and the marketing team have access to this printer as well. The fourth branch is Rochester, Minnesota. Like branch 3, this branch also uses VLAN connections through the router for IP addressing in the HR and accounting department. The HR and accounting servers provide IP addresses for their department using DHCP. There is also a wireless access point located in the HR department, which enables wireless internet. This is useful because other wireless devices can be added to the network without physical cabling. This network has a strong connection and utilizes all resources in the branch to its full capacity. The final branch is created, which was the headquarters. This is the most important branch out of all of them because it is specially equipped to connect and distribute information between all of the branches altogether. This is the central unit that pieces the entire company together. Similar to the other branches, headquarters uses a router on a stick too as part of its structural base. This is beneficial for the headquarters and adds efficiency and effectiveness. As you can see from the 5 branches, creating a network for a large company like IBM is not easy. It takes a very strategic plan in order to make the network secure, reliable, and quick for its users. I hope you enjoyed my presentation today. Thank you for watching.